Today with Sana, I'm going to talk about the robotic welding machine. What is robotic welding? Robotic welding is mainly used as a means of automating the welding process and increasing accuracy while reducing the time needed to finish the project. Doing things faster and with greater precision is the main reason why robotic welding systems are used instead of a manual metal churning. So several industries have already completely adopted robots to help with automated welding. For examples, the industry sector and automotive industry where things need to work fast and with a lot of precision. History of robotic welding. The origin of robotic welding can be traced back to 1962 when a robot created by George DeWolf and Joseph, dubbed the Unimated 001, found its first real-life applications. The first job was to perform spot welding tasks on an assembly line in a General Motors company. So, however, it took some time for the robotic welding system to find its ground and only began receiving wide acclaim in the 80s when robotic welding processes were predominantly used by the automotive manufacturing industries. So much usage brought to the evolution of robot welding. So today we already see ones that have advanced motion, control and 3D vision, making these machines more productive and functional. How robotic welding works. So bringing in a welding robot requires changes that are supposed to accommodate automation, while welding robots use a variety of tools that are not part of manual equipment. Rectilinear types of welding robots are able to move the arms in three dimensions, while articulating can move in more planes. So a wire feeder will send the filler wire to the robot while a high heat torch at the end of the arm melts the metal. The combination of two is usually what robotic welding processes are comprised of. So the temperature can get very high, so using a robot instead of a human increases safety. So therefore, human workers are still needed, but an operator is certified by the American Welding Society to oversee and inspect the entire process. So they use a teach pendant to perform the controller. The device will then set new programs, change parameters of the process, and move the arm as needed. Robotic welding process. So robotic welding process have higher accuracy, less waste, faster operation. So some of the main welding process that robots are capable of doing are arc welding. Arc welding is a electric arc between an electrode and metal base produces an intense heat to melt and intermix two parts. Arc welding is used for applications calling for high accuracy and repeatability. Second one, resistance welding. A current which is passed between two metal pieces of metal. A pool is formed by the resulting heat and the two pieces are joined together. So the resistive welding is the most economical form of robotic welding and is the best for heat treating projects. Third one, spot welding. Spot welding is a type of resistance welding. Spot welding joins thin metals that resist electrical currents. It typically used in automotive industry to join sheet metal frames together. TIG welding, a high quality process where an arc is formed within a non-consumable tungsten electrode and the metal part, which is also known as gas tungsten arc welding. TIG welding is used when precision is of the utmost importance. MIG welding, a high deposition rate process that involves feeding a wire continuously towards the heat welding, also known as gas melt arc welding, is best for applications where system simplicity and speeds are desirable. Laser welding, a laser generator delivers via a fiber optic cable a laser light through a robotic cutting head to weld pieces together. Laser welding, including remote laser welding for hand-to-reach weld locations, is often used to high-volume applications that require high accuracy, such as automotive sector or in medical or jewelry industries. Process sensing. A robotic welding is a complex combination of not only robotics and welding but also combines sensor technology, artificial intelligence, and control systems. Robotic arc welding applications use a variety of sensors depending on the function sensor and can be either process or geometrical. The process sensors measure the parameters of the robotic welding process such as wire feed speed, current, voltage and torch rotation, whereas geometrical sensor measure the joint geometry like gap size, deviations from the nominal path and weld size changes and orientation changes. These sensors are also used for seam tracking, weld searching and real-time adaptive welding. Pros and cons of robotic welding. Pros are there are many positive sides that have convinced a lot of business to employ robotic welding in their various purposes. So there is increased efficiency, accuracy, better safety, fewer cost, less waste. Whereas the cons of robotic welding are, however, while helpful, there are still some downsides to robotic welding applications. Lesser flexibility, higher upfront cost, not applicable for smaller projects or smaller industries. Key issues. So even though introducing robot arc welding or robotic welding sounds like a very good idea, but automated robots can quickly fill the skill gap created by programming, and using this type of equipment is complex for regular operations. So since our technology has come a long way and its availability as well as reliability has increased over the years. So however, it is still not possible to efficiently and effectively apply them to a certain applications that were like temperatures, the spatter from molten metal, the light from the arc, and a dozen of other factors that come with welding are going to interface with the sensors. Cost justification. So it seems that it has become justifiable to use robots in production as opposed to humans in terms of cost. So robot applications have started to offer good quality and perform at a lower prices. On the other hand, labor and benefits laws have risen. It takes a lot of training to create skilled welder, and they still remain scarce in some parts of the world. Environmental safety factors also justify robots for industrial work. Failing to comply with OSHA and EPA standards can be expensive. Training and certifications of robotic arc welding. The AWS certification program for robotic arc welding, whereas operators and technicians CRAW certifies the professionals needed for robotic operation. Certified technicians are equipped to work in accordance with the certain standards, codes, and specifications, but there is a re-examination and proof of active practice are needed every 3 years. We have future of robotics. Well, so currently a robotic welding accounts for only a portion of welding projects for various industrial work, but we are expecting the application of robotics to increase as innovations continue. So industrial innovations that are expected are ease of use and ability to work with other machines. So the growth in transportation and automotive markets, technological innovations will continue to improve productivity. Thank you.